At the moment, I don't see anybody remotely joining on Jabber. If someone wants to consider being Jabber Scribe, that would be great, but it may not be necessary. And I'll try to keep an eye on it here too until we get a volunteer. Note-taking. I don't mind taking notes myself since we have a small meeting.
I'll try to do some.
Okay, yeah. Yeah, Victor and I can kind of share note-taking duty up here, so I don't think we need a third party unless somebody really wants to do it. But Jabber would be helpful since that's a little more involved. Okay, I guess we're going to get started. Welcome to the Network Coding Research Group. Up front, we have our IETF IPR policy. Basically, if you know of IPR, please bring it to our attention, or you have an obligation to do that as you participate in IETF and IRTF meetings. If anyone has any questions about that, please ask Lars. Here's our agenda for today. Basically, the first presentation is a new participant we welcome and look forward to that presentation. And then we have some updates on some of the existing drafts that we have in play. And Morton, I don't know if Morton's here yet, is he?
He's not.
He actually kind of is working on a survey of papers and had listed a few things on the mailing list. And he didn't feel he was quite ready to do a full presentation on it. We thought it would be worthwhile just to post some of the papers that he's found and people have referenced so far and bring them to the attention of the meeting room here. And if anybody has any verbal comments, we'll certainly make note of those. And finally, we have a couple discussion topics at the end of the meeting. We'd like to talk about the tutorial or tutorials that have been discussed on the mailing list for future events, possibly a segment of an IAB technical plenary if we think that makes sense. And then perhaps a second more extensive tutorial that would be somehow offered outside of the meeting agenda that maybe even would offer a hands-on look at how network coding can be applied in different systems. And finally, we'd like to, if there's time, revisit the architecture discussion a little bit. We don't have a lot of new stuff to talk about there, but Victor and myself and some others have discussed how we can clarify the sort of definition of what we were calling building blocks versus other architectural function or components. We have a few slides on that. So with no further ado, I'd welcome Angeles up to talk. Or yes. And there's a microphone over there. And they like you to stay in the pink box. Is this different slides? I have your slides already. Okay. Make sure these are the right ones.
I think so, yeah. Good.
Okay.
Okay. Hello, good afternoon. So I'm going to present this work with title System and Layer Independent Network Coding Architectural Design. So this is non-common type of presentation in this IETF, IRTF, I know. That's why I will devote some time to explain why we are here, and it's also a European flavor thing, so that's why I will present. So I'm representing here what is called a cost action, which is a European network of experts, European Union funded. I lead the working group 2 on practical aspects of network coding, and then I also present contributions from these colleagues of mine that I will present later. So the layout of the presentation, I intended to be short, not too long. The first context, what is a cost action, and why it could be helpful here. And then I separate the contribution in two parts. First, the proposed architecture design methodology. I also explain why such a proposal. Then I try to justify why network coding could be considered as a network function to service-oriented systems, and then what could be an architectural design framework. In the second part, I introduce the validation of these ideas, meaning that they can work, for example, with these two big systems, access systems, LTE and SATCOM, and communications over satellite. And then some next steps. So, please. Okay, context. What is a cost action? What is this? Who is contributing here? So, cost actions for, may I ask here how many European people are here? And Americans? Ah, okay, 50-50. Anyway, so this, maybe Europeans even don't notice because it's mostly academic, scientific area. But Americans, I'm sure, maybe not. So cost actions started in 1971. It's a European scientific tool to bring together researchers, but it does not fund the research itself. The researchers that are brought together are supposed to be already working on related funded research projects. It's what they call the European Research Area. So, for example, in the period of between 2007 to 2013, what it was called the 7th Framework Program, it was a fund of 250 million euro. So, the cost actions are not supposed to do the protocol. It's not supposed to do implementation. They are not supposed to even really do any political decision. Do nothing at all. And that's why I'm here. I like it's a very independent. So it just brings facts. These are scientific facts. We let you know, you decide whether to use them or not. Okay, so this is the idea. And it has worked in the past, at least in Europe. For example, there is some successful dissemination of scientific results of cost actions. For example, the COST 207 provided the channel models, which serve for standardization of GSM and Edge. COST 231 are very famous too, and they are even being used today. Then less known, probably very known for me because it's from the satellite channel, from the satellite community. The cost actions 255 and 280 provided the satellite channel models who are all being used to develop the DVB standards today. If you know them anyway, they are used for that. And also the COST 259, the same thing. So this presentation is also a dissemination activity of scientific facts that are related to network coding that could be useful here. So our cost action is on network coding. The chairmen are Markus Greferath and Mario Svin from University of Finland and Croatia, respectively. So this is important to know. They are pure mathematicians. This means that this cost action has a very theoretical flavor. There are many pure mathematicians working on that. And this is also a reason why I'm here, because a lot of this mathematical work is lost and remain theoretical when it could be very useful for you, should you know about them. So it is a very European thing. Also, the European Commission wants to bring as many countries as possible. We are 27 at this point in time. And these are the working groups. So the first one works on bounds of the size of network codes. It's integrated mostly with mathematicians and theoretical computer scientists. This means that every presentation starts with and ends with theorems. But are these theorems important for you? Yes. But we will talk about that. Working group 2. This is the group I represent and the group I'm leading. And still, we are 50% engineers, 50% mathematicians and computer scientists. So we deal with looking around at what our colleagues are doing and trying to use that as much as possible and make it in practical. That's why we are here. Then working group 3 works on cryptographic aspects. Only mathematicians and computer scientists. I don't know almost what they are doing, and I don't want to know. Working group 4, constructions of network codes and Grassmannian codes. This, some of you may wonder what is this, but you would be surprised that you are doing this already, but you don't know that this is that underlying algebraic object that you are using is a Grassmannian. And the final working group, foundational aspects, it's also algebraic methods, but also they look a bit on distributed storage. And you see that mostly mathematicians and computer scientists are working here. So this presentation is dissemination activity of working group 2.
Just quick question.
Yeah.
So the people working multiple groups, or
Do some of the same people work in different groups?
Yes. I forgot to say that. This is important. Yes.
And I guess one other question was: is there sort of a timeline for this activity?
Yes.
The cost action group. Are you going to get to that later, or
This is this particular any action lasts 4 years. This is from this one is from 2012 to 2016.
Okay.
So next year we are done. And this is I forgot to say this. In fact, next year is already last year, but in this cost action we have been a bit slow because of the high interdisciplinarity. I think we took almost 2 years to understand each other, or to start to understand each other.
We understand that completely.
Exactly. That's why I come with ideas on how we can talk, because we start to manage here. And moreover, we have also all these countries with each of them with its own language, and universities we didn't know even existed, and we are trying to understand each other. This is what I call the European flavor of the work. So, yeah. Okay, so then this contribution. Again, I insist the work, the research work, the facts I bring are developed within the cost action, but it's not funded by the cost action. It's funded by projects that the cost members have on our own. In particular, this the cost members that we are contributing today here have projects dealing with network coding, already implementing network coding, funded by European Union and European Space Agency. In particular, we have these colleagues from University of Lancaster and University of Novi Sad in Serbia, and they work on layered multimedia transmission using network coding, and they have some facts to say, which are these, and they focus on wireless terrestrial access, in particular with LTE. And then our group, which is from Barcelona, Autonomous University of Barcelona, and my colleague that was my former PhD student, now with Answer Technologies in Norway. And we have also some facts to let you know in case it's useful, ranging from very algebraic content, which is what is going to be presented in information theory, down to very, very pragmatic implementation of network coding, both over satellite and not. So this is the contribution. So I start now with what is the message. So first part is what is the proposed architecture design methodology. So in order to introduce it, I always like, I think it's the third time that I said this, I like to see the evolution of the network coding concept, so that we still today see it as an evolution, as a concept that evolves, because this also makes sense on the type of framework that we propose. So the origins of the concept was the error-free networks. So we all know seminal works, and these seminal works were developed by computer scientists. So the main result is network coding makes it possible for a source to achieve a multicast rate equal to the minimum of the max flow to the individual destination, meaning finally we can achieve multicast capacity of the network. Now, these origins were followed up again by computer scientists, adding some algebraic formalization, coding theory, and control theory. For example, we all know now that we have this, the network can be algebraically very nicely described analytically with these matrices, and we can achieve the max flow, the min cut, by as long as this transfer matrix is non-singular, and these other seminal papers, like, for example, randomization or constructions. Now, after this seminal work over theoretical error-free networks brought the concept was seen to be useful also for wireless networks. So now what happens? Once we enter the wireless networks, the seminal works don't come any longer only from computer scientists, but also from telecom engineers, because the telecom engineers are the ones touching the radio resources. So the follow-up was same concepts as before, but now instead of combining packets, now the combinations are of lattice points, meaning that the algebraic objects underneath are different, but the concept is the same. And finally, the key thing, I think, in this group, which is it evolved further to network coding for error correction. There are mainly two big streamline work for this, which is the coherent approach, where network error correction is seen as a generalization of classical link-by-link error correction, with these people having this line of work, is quite information theoretical. And then the non-coherent approach, where network coding and network correction over network-coded networks can be tackled as separated problems. So this is a very innovative way, and brings the different coding approaches like subspace codes. And in fact, this is the main expertise of the cost action of all these mathematicians. They can give you whatever you need in this type of thing. Okay, so with this evolution, very short introduction, I could dwell a bit more, but with this very short, I come to the rationale of this proposal, which is that this network coding concept is still evolving, and consequently, unified theoretical framework is still missing. We have that network coding theorists abstract away network system layers, and some codes unfortunately remain theoretical. Network coding theoretical computer scientists work with logical and mathematical network models for analytical treatment. And finally, network coding engineers design network system specific, possibly physical specific as well, solutions, and analyze performance, even abstracting away the network codes. So they all work in the same thing, but they abstract different parts. And the problem is that sometimes they cannot interact. So that's why it's the rationale of this proposal, that we can all interact. So the mathematicians can give you these very powerful codes they have, that you don't need to understand. Okay, so then, together with this, there are simultaneously evolving concepts also around of networking system and services, which in general, the common thing in all of them is that they involve higher level of abstraction, because the more complexity the network, the things have, the higher level of abstraction is needed. So this is very clear, for example, in European research activities related to 5GPP. You can go there. There is a lot of things. And also future networks, like, for example, the plenary talk this morning, that is again the same thing. So, okay, so then our proposal. Our proposal has the objective to provide an operative framework for the design of the dynamic structural properties of the network communication flow. So we need a name, and the name is the network, the communication network flow, the communication network flow, and we separate the typical coding reliability terminology for something else, something more powerful, and that actually comes from the network coding origins, because the key seminal paper is the network information flow. So what is meant by structural properties? What you have to transmit inside the protocol transporting information, so that any design goal is optimized, is achieved. These dynamic structure is to be signal transported by one or two-way protocols, and it needs interdisciplinary design. So how we achieve this? With a configurable, reprogrammable architecture. This means that it should be network code independent, system and layer independent, and specialized, because this is a 5G fashionable thing, service oriented. So this idea seems to comply with, but not constrained by, 5G ideas and future network concepts, and seems to be in line also with other proposals in this research group, which is called here functional building block-based architecture. But the only thing is that our proposal introduces a higher level of abstraction and a framework that allows to get the best from all the communities. To be seen if we are compliant also with other, time to see that. Okay, so then how we manage, how we propose that there is interdisciplinary interaction by cutting the interdisciplinary body that we have into coding domain, per node functional domain, and protocol domain. This means that in the coding domain, there are the coding theorists giving us what are the performance benchmarks, but then we have to ask them by the appropriate mathematical to logical maps, because we cannot just get the algebraic object. We need to map it into things that we have, packets, let's say, and encoding, decoding algorithms, and so on. Then the functional domain is what allows to shape the structural properties of network coding, practical versus theoretical. Here, what I think can be helpful to understand what I mean here is that even if network coding is for maximizing throughput, maximizing reliability, and so on, maybe as the service provider is interested in optimizing the user experience. Hence, it's not or the energy consumption. So it's not interested at all to use the full reliability capabilities of the code at all. What the designer needs is to access this reliability capability and tune it as needed. So how we can do that? Well, we can do it by abstracting network and system, by capturing the main characteristics of both at the network, obviously, at which layer we are, but not only for example, this morning we saw for the vehicle networks, they have their own 5G, they have their own layers. Now every system have their own layers. That's why we virtualize everything, and then we say, okay, our network coding, where is it needed? Between this and this. That's it. And that's why here it's related to software-defined networking, function virtualization, and all that. And finally, the protocol domain. Because I told you that system designers are not protocol thinkers, and vice versa. So I think it's not good that one person, the protocol designer does everything. The key thing is that there is interaction among them. Yeah. Now this is just a graphical representation of what what I just said. We have all the all the real things, and then we abstract what we need. We have also all the theory there that is useful for us, but we have no access to that. And this would be taken care of by the coding domain, and then we have the functional domain and the protocol domain, which and we should interact with other frameworks, because this will be a functionality. Yeah. Okay. So does this work? Okay. So what I did is I came up with these more or less ideas in the SATCOM, because my main research is the SATCOM area. So then I talked to my colleagues from the cost action, and I told them, okay, all this work that you have done in LT, try to fit it in this framework. So it was like a proof of concept, right? So then we see that it may work. So please. Yeah, so this was the methodology for validation. We identified the common functionalities and network coding design needs for system specific. In particular, these two systems that the network, the engineers in the cost action were working with. So then we identified which were the common functionalities in all the systems, and we came up with this, some core functionalities that are always there, interoperability functionalities that are very, very, very much system dependent, and then some console functionalities to access to set everything, because if it is virtual, you need to tune everything. So, okay, so then this is just the first validation in the long-term evolution advance, just to for the Americans to know that this is the 4G mobile broadband wireless access, and this is defined by ITUR, and I am well, that basically is one option, and another option is the American 802.16. So it is 4G is not 5G, because in a way all these ideas are already oriented to 5G, but it already has a quite complex protocol stack, but quite structured. So it will be easy it is more or less easy to virtualize this, because it's very well structured. Anyway, I have here.
So the blue boxes are where extensions to add network coding. Sorry? The blue boxes?
No. This is just the example.
Oh, the text is not clear. I thought that said RLC, but it's RLE.
No. This is only the protocol, the example of protocol style of LTA. No. Just to introduce that, and that they, and then also that they talk about IP flows. So that's why we would have a coded flow. Now. So my colleagues in the construction, their particular network coding was for a multimedia transmission with layered network coding for LTA. So then they used the well-known concept of layered coded multimedia service, represented by different layers. Base layer, first enhancement layer, second enhancement layer, that can be tuned how many layers you want, depending on the channel conditions, everything of many conditions. So this network coding can be performed on each layer independently, and what they do is just expand what they call expanding window, with operations are in a nested structure of expanding windows. But again, in this, we have a lot of materials and codes in specific network codes with Mathemata. But in this first introduction, I wanted only to focus on the functional architecture. And in this case, the position is between the MAC and the FI. The most important layers are better protected than the least important ones, with their own proposal of code. Now, their design goals are very different, and this is the reason why that supports what I said before, that is not only reliability what you need from network coding, but to have access to what you can get from network coding. For example, there they minimize the number of transmitted packets while meeting a minimum set of service level agreements. So this first is clearly a service provided point of view to use network coding, and or maximizing the quality of experience. So this is a user-centric point of view. So then, abstracting what they did, they identified the functionalities. So then, for the functional domain, remember that we have the coding domain, the functional domain, and the protocol domain. The functional domain would be this. And remember that we distinguished between the core blocks, the interoperable, and the console block. So we just, and here we can have many, I think we have many. And then, for example, the flow of information between the different.
You might want to move the mic because we have a few people online that are listening.
Okay, sorry. The flow of information between these blocks, in this case, are very specific of their design, but can be, of course, generalized. So this would be this just helps to visualize how the flow coming at the MAC layer is transformed by these functionalities and transported in this interlayer. And this is just an illustration of performance that they get a big gain by using network coding compared to classic approaches. In this case, with 4 levels of QoS. Of course, I don't go into details here. If you're interested, all the papers are very well. Okay, and then the second system with which we validated the work is the digital video broadcasting DVB, second generation S2X extension RCS. So this is in a way equivalent to the LTE, but in the satellite communications. It's actually a very widely spread interface standard in the satellite market, and it is. I myself was involved in the standardization of DVB-S2, and it really works also on common building blocks and in interdisciplinary interaction. And already the DVB-S2X incorporates packet level forward error correction. But at that time when we did this, there was no network coding yet. So that's why we said, okay, what if we do we replace by link layer systematic network coding, LLNC. So we did work it out, and we placed it in between IP and MAC. The dimensionality of network codes is compatible with the standard. Network coding dynamic properties depend on channel conditions and congestion, because in this case we have the adaptive coding and modulation in the lower layers. Now here, the protocol we use to carry the network-coded flow is generic string encapsulation, which is a carrying protocol common to all the DBB standards. So we call it encapsulation. So I don't know what is the difference exactly, because this I know very well. So I don't know the difference between this and the protocols here, why it's not converging this thing. That would I'm particularly interested in why this mismatch. And again, we have different goals: maximizing quality of service and quality of experience. So please next. So then we can abstract the underlying system by going logical. For you, maybe this is very normal, but for system designers and satellite, this is not normal at all. They need to see the satellites, but the satellite is not here, may or may not be. So in this case, we are just with two hops, and again, the functional domain. We were able to identify the functional domain with the appropriate flows between the blocks. In this case, you see that it is per ID node, so you may need to have different functionalities depending of the ID node, and interaction with external functions and frameworks. This is also illustration of performance. We do have 53 higher reliability that the current packet level coding in the DBBS2 standard. We know why and everything. And since we consider also all the theoretical mathematical models, we know exactly how far from the benchmark theoretical we are, because we can interact with the mathematics, and that's it. So then conclusions. This is system layer independent network coding design framework with some validation within the cost action, and seems compatible with incoming ideas in design frameworks. So we have some next steps within the cost action, which is further elaboration, of course, and then to go into the coding domain, protocol domain, and whatever is interesting. So this is all. You can.
We do have one question from the internet audience. I'm not sure who the user is. It says it on the previous slide. It says, I do not understand how the network coding interacts with the HARQ of LTE. So it's probably back a few slides. So how the network coding interacts with the ARQ mechanism within LTEA. Do you have any?
As far as what I understood, of course, this should be is a question for these specific authors. I have the feeling what they do is to replace this queue with network coding.
Okay.
This is what I understand.
Hopefully they heard that answer. Okay, I think this is very relevant. There's a lot of commonality I see in the functional architecture that you've put there with some of the things that we are still trying to do within this group. So you represent one of several working groups that are working in this area. Do you know if it would make sense for us to reach out to any of the other working group activities for them to present something here as well, or
in the other working groups of this cost action?
Yes.
Yes.
Okay.
Sure. Of course.
So that's good. And understanding the time frame that this cost action is occurring in, of course, puts some urgency on. Yeah.
No, I already invited the mathematicians to also.
Yes, understand. Okay. Anyone else have any? Victor.
So I have thank you very much for coming. Okay.
Victor Ferrer, BA Systems. Thank you very much, Angelos, for coming here and presenting. This is very interesting. This is clearly it's relevant and germane to what we are talking and doing here. Just a quick one. I mean, you've presented a lot. You've presented. No, it's nothing specific to a slide that I have a question. It's in general. Obviously, you've presented a lot, and you went from all theoretical work to I see practical, and even as far as I understand, some proposals for practical, even protocols that, and I was just curious, how do you see that? Is this just, is this, I suppose this is still a research work that you're doing, but I see a lot of LTE, 5G, 5G PPP. So is there a plan on your side to, or the whole cost program, is that the cost action program, is there a plan to actually move into some kind of standardized protocol toward 5G and so on, LTE? No.
The cost action, the technical project manager of the cost action is very happy that we go here and we disseminate the work we are here, but that with that he's happy.
But just one quick follow-up. So, but since you mentioned a lot of 5G LTE, maybe you've already had interactions with those groups.
Yes, I am I am member of the 5G PPP ETP.
and you've presented this, and I was just curious, how are
not yet.
Oh, okay.
Not yet. I am involved, and I did contribute with some ideas, but at this point in time, there are calls for contribution.
I see. Okay, so that means there is a starting interesting need to standardize on their side as well. So we might want to make a connection with those folks.
Does the cost action group here host a website or a wiki page or something that we could point from our site that has a repository of papers results?
Yes,
okay.
It's not up
did you
to date, but
did you have
I
it
will
listed in the brief somewhere, or I can send you an email and maybe we can post on the mailing list, and we may actually
maybe not.
put a link in our
Sure.
working group's wiki page to point folks to that resource.
That would be great.
Okay. Very good. Thank you. The next presentation is Vincent.
Okay, thank you. So let's start. So this is a follow-up of some work we did with others in previous working group, IETF working group this time, called FEC-Frame. And we specified this protocol, well, this architecture, this framework called FEC-Frame. And I will elaborate on this and show you how we can improve or evolve, make this standard evolve. The usual not well, we didn't try to patent anything or not aware of anything. And if you disagree, then let us know. Thanks. So, as I said, there is an existing RFC, 6363, published in October 2011 with Mark Watson, Ali Began over there, and myself. The goal of this document, of this framework, is to be able to add protection to real-time flows in a very flexible way with unicast or multicast flows. And this is an IETF standard. This is also included in 3GPP multimedia, broadcast and multicast services. So this is something that is or will soon be used broadly. The architecture for this FEC-Frame stuff, so the RFC 6363, is pretty simple. This is not exactly a protocol. This is more a shim layer that fits between the RTP on the top, the application, and most of the time the application uses RTP for encapsulating real-time flows, and the transport protocol at the bottom. Most of the time that will be UDP. It can be something else. So you plug something else in the middle. This is the FEC-Frame framework. And it works with one or multiple FEC scheme building blocks. So you have this source data flow, or you may have also several source data flows that goes through the FEC framework. You accumulate some source symbols, you create a block, and then you do encoding, and then you send, in addition to source packets, you send additional fake repair packets. So it's essentially a way, describes a way to do that in a flexible way. Next. So the key design to fake frame is flexibility, as I said. There can be one source flow, there can be multiple source flows, there can be one repair flow, there can be multiple repair flows. You can imagine several ways to combine them together. Several mappings are possible. You can work in unicast, multicast. You can be also, there is also a backward compatible mode where legacy terminals won't break if they receive flows with fake frame packets. I don't want to go into details. It can be deployed in end host or in middle boxes. It doesn't make a big difference. So here also most of the technical details, most of the signaling part is in the fake schemes. So this is where all the complexity will be. And in this IETF93-NWCRG-20150721-1520, we have two key constraints. The first one is that there is a single encoding point and single decoding point, so there is no in-network recoding possible. And the second limit is that it is limited to block codes, block AR fake codes. So we standardize RaptorQ, well, Qualcomm did that. We standardize on our side Rich-Solomon, LDPC. There was also something else for simple two-dimensional XOR codes. Next. So what we want to do with this next version for fake frame is to be able to add some convolutional codes inside in a backward compatible way. That is to say, we want to be able to do a sliding window encoding for those flows with convolutional FEC codes. But at the same time, we don't want to break anything because there is already deployment, or there will be deployment soon. So we need to be backward compatible. So a sender may be should be able to use legacy block codes, the ones that have been specified before. And the motivation for that is quite simple: reduce end-to-end latency. We have an issue with IETF93-NWCRG-20150721-1520 since we are using block codes, traditional block codes. It means that you cannot produce and send any repair packets until you have accumulated enough source packets to create your source block. So you need to wait until all of the source block, all of the packets for source packets for a source block are available before you can do encoding, before you can transmit repair packets. So the decoder, the receiver, won't be able to recover any erasure until the end of the source block, until the reception of the first repair packet. So this is something we want to remove in order to reduce the latency end-to-end. So I have several comments, one question. Comments, well, if we look at IETF93-NWCRG-20150721-1520, we see that I believe that there is no major problem in making this standard evolve. Adding convolutional coding into IETF93-NWCRG-20150721-1520 is something that is, in my opinion, as far as I understand today, simple, I would say. That's the first comment. Second comment, we already support multiple flows in this IFC. We already support intra-flow coding or inter-flow coding. There is a mechanism to do that. There is a flow identifier. There is there are a few things like that that makes it possible. It can work in a single flow. It can single path. It can work multipath. It's not the problem of fake frame. It's more a matter of the transport protocol below. If you are using the same destination multicast address, then it will be single flow. If you use two different port numbers, then it will be single flow, but with two flows into that. And if you use different multicast addresses, then it will be typically multiple paths. Okay, so that's already supported. And next point, which is more an open question, is about the possibility of doing in-network recording using fake frame v2. It was not considered in the original IC for one simple reason. It was based on block codes, and with block codes you can do recording. In order to be able to do recording, you would have to do decoding first recover all the source symbols before being able to do recoding after that. So it's totally prohibitive, just forget it. So that was not possible to do in-network recording with FactFrame, but since we are considering convolutional codes, this is something that is now feasible. Okay, so the question is it worth doing that? Technically speaking, I think it's possible. I have my opinion on that, but I'm open to other opinions as well. I think it's possible. I think it's something that we could add to this, to FactFrame v2. Next. Next slide is about FactFrame v2 versus Tetris. So if you look at it more carefully, you see that there are a few differences, but no fundamental differences, I would say. The coding techniques are a little bit similar. There is just one question about elastic sliding window. Elastic sliding window is feasible with Tetris since there is this feedback, and with FactFrame there is no feedback possible, so you won't be elastic if there is no feedback, for sure. You won't be able to adjust and send the encoding window if you don't know in advance that such and such packets have been received on the other side. So. But otherwise it's pretty similar. Signaling is totally different for historical reasons. Tetris has been designed from scratch. FactFrame already exists, so for sure there were different options. And we won't change FactFrame. We won't change the signaling part of FactFrame in general, for sure, in order to remain backward compatible. And a third point, there is no feedback. There was no one of the design constraints of FactFrame was to avoid feedbacks at FactFrame level. Of course, if you are using your RTP flows, you have the possibility of having RTCP feedbacks, but that's managed at the upper layer, not within FactFrame. You may use that anyway for adjusting the coding rate, but that's all we can do. So on the other side, on the opposite, Tetris can use feedbacks, especially in unicast or with small multicast groups. So that's a big difference. And now, if you are considering large multicast groups, Tetris cannot scale with feedback. So in that case, Tetris and FactFrame will be quite similar from a functional point of view.
I have a question. I mean,
yeah.
I know that FEC frame kind of as designed didn't provide for a feedback mechanism, but it does not necessarily preclude creating a feedback mechanism that's based on the FEC frame encoding symbol IDs, right? I mean, that's not,
yeah, we
not unlike what we did in RMT with the...
Yeah, we could do that for sure.
Yeah.
Sure, we could add something in order to be able to do feedbacks, but it's not part of the RFC.
I understand that, yeah.
And the use cases that were in mind were more on the broadcast side. So in broadcast systems, you don't necessarily have the capability to do to gather feedbacks from the terminals, because this is a unidirectional broadcast network most of the time. So I think this is one of the reasons.
Yeah, I just think there is possible use cases in the broader perspective of what we're looking at, the network coding research group, for example. If you recall the on-ramp, off-ramp concept that was presented a couple meetings ago, you could have middle box points that would use feedback to make sure they had a complete decoding of packets that they were maybe forwarding or recoding to a you know, from the backbone network onto exit ramp or whatever the terminology was used at. It could be useful to build some feedback mechanism around FEC frame, or do you think we should just be using Tetris or something at that point instead?
Well, I think that one of the constraints for the FactFrame working group or the charter was to avoid mixing IQ and
yes.
purely fake approaches. So they decided to do that in the just with fake FEC encoding.
Okay. So you really do see this as pretty much an bona fide FEC frame v2 specification as opposed to an adaptation of FEC frame to meet greater network coding needs. Okay. I understand. Okay.
And next slide. So next steps. Well, we have this open question. Should we do in network recording? I think it's possible, and probably a good thing.
And I think that's the distinction that makes it more of interest to the network coding research group than just being a transport area update to the FEC frame.
It will have some constraints on the FEC scheme that will be used, so it's not something that can be used with any convolutional code. So, but as we will see with Tetris, there are techniques for doing that. So that's one possibility. And then next step can be to update this IC. It's not that difficult, technically speaking. And well, work on the FSC schemes in parallel, of course, just to make sure, well, to have something usable and also to make sure that the design is correct, that there is no big flaw in the design.
And this is sort of a question for Lars, but I imagined if there were an update to the FEC frame document, which was a transport area document, it would be done in the transport area. Yeah. Yes. Yeah. Okay.
That's all.
Let me double check the Jabber here to see if somebody's typing something, so there may be a question from the outside world.
I would say we can still discuss it here, but
the actual standardization process goes there. But
of course,
it's important.
This is something we will discuss with Ali, for instance. Go for this IFC.
Okay, I'll let you know if a question comes in, but otherwise we can. Unless there's any questions in the room, we can move forward to the next question.
So just one quick, very high level. So this would be a way to do network coding using this little bit of an extension of FEC frame, add the convolution code, which could be, for example, random linear.
Yeah.
And in terms, but this would be only source coded, meaning that the issues of actually, I think you touched on the possibility of having feedback or not in terms of getting reliability. I'm missing.
No feedback for the moment.
Not okay.
Your feedback's possible, but that's
right.
Else.
So inside at this shim layer would not be any.
No, I don't think we need to. Well, I think we must not use add feedbacks within FECFrame itself because it would break many things. And it was designed this way, so it's not. The goal of FECFrame was not to be a generic, widely used protocol. It's more something specific work in a specific for specific use cases where it makes sense to have this capability to add FEC packets inside our real-time flows. So it was designed with this in mind, and let's keep deciding.
Yeah, so we do have a Jabber question, and the question is, and I suspect it's possibly more directed at the entire group than just you, isn't in-network recoding the main feature of network coding? And I think that certainly echoes my sentiment that if you do extend FEC frame to support re-encoding, it does become a viable tool for network coding application. But if you have a different opinion, please.
Well, we can discuss this big question.
Yes. Okay.
Should we necessarily do in-network recording in the network coding research group? We can open this discussion if you want. Anyway, we can, I think, easily do in-network recording if the use case makes it, well, requires it. If there is some added value, some benefit in doing that. I think this is a feature we can add to FECFrame quite easily. So most of the time it won't be the case because it's just a broadcast network with a broadcast server, and that's all.
As a research group instead of a working group, I think the question's kind of academic anyway. But it's important. I mean, I do think that this is good that you bring this here because it certainly becomes a tool that we can use for network coding.
Yeah, I think it can also. It's also an opportunity to think on some topics that will be important for the network coding architecture.
Yes.
On work on some building blocks within the network coding group. So it's also why I'm presenting it here. Let's see for the future.
Okay, Jonathan's up next to talk about Tetris.
So, I have non-academic question. Blue sheets, please. I've seen a lot of people coming in after we send out the blue sheets. Can you please pass around and everybody can sign? Thanks.
Okay, so hi. I will present some updates about our drafts concerning Tetris. So next slide. So before starting the note well, so please read it. Okay, next slide. So what's new in this version? So the first thing we added is a deterministic method for recoding in the intermediate nodes without the need of transmitting the coefficients in the encoding vectors. We modified also the encoding vectors. We reordered the fields and added a new one to signal the use of variable size symbols in the encoding vectors. And the last thing we did is a proposition for the multicast use case, particularly to manage an elastic encoding window. So this is a simple use case for unicast communication. So you have a server, you want to send data to a client, so you will have an encoder and a decoder. Optional, you could find some recorders in the intermediate nodes. So what we call output symbols are coded symbols and source symbols in a systematic way. And you will have feedback up by up, and it is also optional. So the recorder could generate some other coded symbols without decoding operation. I will talk about that just now. So the principle of recoding in Tetris is use the received coded symbols to generate deterministically new coded symbols without any decoding operations. So how to do that? So we are in an intermediate node. So we have a set of T received source and coded symbols. These symbols have been produced from K source symbols. These K source symbols are unknown. Okay? So the problem is to compute a new coded symbol called R prime as a combination of the unknown source symbols. And the coefficients are generated as usual from the coded symbol ID of R prime and a coding coefficient generator. So by doing that, you avoid transmitting the coefficients in the encoding vectors. So now how to do that? So this is a general case. So in an intermediate nodes, you have the quality. You have so T received symbol as a combination of K source symbols, and the matrix J contains the coefficients. So if J is of rank K, then you can extract an invertible K by K submatrix called J prime. So if it's a square matrix, you could invert it. So let's call M the invert of J prime. So you could express the K symbols unknown as a combination of the K received symbol. Once you have that, you set the ID of the new coded symbols you want to generate. You generate the K coefficient by using a deterministic coding coefficient generator. And by multiplying this coefficient by the transpose of M matrix, you will get new coefficients. And this new coefficient, V1 to Vk, can be multiplied by the received symbols, okay? And then you will get R prime I as a combination of the K unknown source symbols, okay? And you could send R prime without sending the coefficients. So this is how works the recoding in Tetris. So next slide.
I'm just going to pause for a second.
Yeah.
I think Morten's got a question.
Morten Peterson, so if I don't receive any additional symbols?
Yes, so this, as I said, this is a general case. After I will explain. Actually, you could do that if T is greater than K, right? You have T received symbol. And
but then you would have to communicate how you subtract submatrix, right?
I'm sorry?
Okay, let me see.
I think it's implicit. Let's look what he said.
Okay. So sometimes J is sparse, so that means when you receive many source symbols or when the generator generates sparse linear combination, it simplifies the M matrix computation and could allow some iterative operations to generate new coded symbol. It's like an hybrid system between recoding and decoding. We allow simple operations to generate more received symbols. Another case is when J prime is not invertible. So it happens when T is lower than K, or if the linear system is singular. Then you have two options in this case. The first option is to generate a coded symbol from a subset of the K unknown symbols, if it's possible, or if it's not, you could wait a few more symbols. So that means you increase T.
If you generate the coded symbols from the subset, you still not have to transmit the coefficients then?
Yes.
Okay.
Okay, so about the recording.
Sorry,
Yeah.
Morten Petersen, from any subset?
No, it depends. It depends. Yeah.
Okay. All right. So if conditions are right.
Yeah.
And that's what the try means. You
Exactly.
try.
Exactly.
You may not succeed.
So about the complexity, doing recoding with Tetris, you need to invert a K by K matrix, okay? Then you need to do a matrix vector product to generate the V1 to Vk coefficients. And then you need to do some linear combination of the received symbol. Compared to RLNC, if you want to do recoding in RLNC, you just have the matrix vector product and the linear combinations. You do not have the K by K matrix inversion. So in most of situations, the packet size is much greater than K, and therefore the linear combinations of symbols take more time than the matrix inversion. And then, once again, with Tetris, you do not have to send the coefficient in the encoding vector. These are the difference. Okay, so next point, the encoding vectors. So in Tetris, they are sent in the coded packet associated to a coding symbol. And they explain how the coded symbol is generated. So you can store inside the coefficients and the ID of the source symbols in the combination. You also now signal the use of variable size source symbols. Before that, it was not optional. So now if all your symbols are on the same size, you do not have to send the encoding payload size. So all this information is optional, and it depends on the coding scheme. Sometimes if you need for any reason to send the coefficient, you can. But if you do not need, it's optional.
So again, in the case of RLNC, you would send them, but in
exactly
not.
RLNC versus deterministic. Okay, so next slide. A bit more of the multicast use case. So imagine you have a server, you want to send data to a set of clients. Each client has its own decoder. So with Tetris, you have optional feedback. So you have two ways. Next slide. If you have feedbacks, you need to define a strategy to remove a symbol from the elastic encoding window of the encoder or recorder. So to do that, you could remove it if it is decoded or received and act by all the receivers, or you could define a certain percentage of receiver that act this symbol. If you do not have feedback, the elastic encoding window grows up to a limit and then slide around the source symbols, and the older source symbols are removed. So it is simple, more simple, but not fully reliable. Okay. So to conclude, we proposed Tetris as a flexible network coding. So now we added the functionality of recoding at the intermediate nodes, and we added a proposition for multicast using an elastic encoding window. And once again, Tetris is independent of the coding scheme. It depends what you want to do. Sometimes you need to store the coefficient, sometimes not, and it's up to you. So next slide, and that's all. Thank you.
Okay. Any questions, Victor?
So, switching from random to deterministic.
Yes.
My question is, so originally, when the original random linear papers. There was benefit in having random benefits in terms of having a high probability of matrix inversion, etc. So I suppose that so your determinacy has a certain
I think we need to compare.
Algorithm to generate is not just any deterministic, but
I think it depends the size of the finite field you are using, and the coding coefficient generator also. But we didn't.
So, in general, so my very high level question is there something that you potentially lose by going from random to deterministic versus what you gain? Obviously, the not needing to send a coefficient.
One, the patterns?
No, a part of that, yes. Technically speaking.
I don't know. I think I need more tests because we only tested with one finite field size, and we need to focus on this parameter.
Okay.
And I think this is the only parameter which will determine which approach is better. And it depends also the use case you want.
Okay.
So, for example, I didn't talk about multipass, but here multipass is complicated because you will send repairs codec symbols in different nodes, and sometimes T is lower than K, so you cannot do recoding.
I see. Okay, thank you.
We do have a comment from Jabber saying that the advantage is about being able to do consistent testing over time, and some comment that it has been done by other people. Not sure.
Yeah. This was also my comment, Frank Fitzek, TU Dresden. There have been a lot of trials to make it deterministic and showing that you can recode. Raptor codes have done that. Fountain codes have done that. They can one hop, and they know that the overhead is great in that. And if you don't want to step on any patterns because of that, then you should also avoid the feedback, because the coding and the feedback is also in the patent.
Yes.
Okay. I guess we'll move to the next.
Thank you.
Thank you. Thanks. I think the next presentation is really just some slides to kind of provide a backdrop for some of the discussions that we have on the agenda.
So we had before this, I think we had, if you go back to the intro, we have a slide or two on the sliding window. Morten, if you want to say a few words on.
Yes, your paper search.
Go.
Is it in this
Yeah.
Okay.
Just go down.
Okay, yeah, so
a second to make it. There we go.
Okay, so that was on a tutorial, one slide or two, and then go ahead.
Okay.
Yeah, so Morten Petersen. So I just sent to the mailing. We're doing a small survey on the different sliding window coding schemes that people have come up with in order sort of to understand how we can take the different mechanisms that people are using and then, divide them into sort of functional building blocks like coding coefficient, selection, and window management and that kind of stuff. And so these are the papers that we reviewed so far. And we will put our sort of, we will make a sort of small document describing our overview, our review, but we would be very interested if people have like other sliding window coding schemes that they think could be interesting for this survey, such that we sort of cover as broadly as possible the different schemes that people have been proposing. Actually, especially if they are sort of significantly different from the ones that we have looked at here, because actually if you look at these, they are very similar in nature. So if you have something that is fundamentally different, then that would be cool. We didn't include the drafts that are in the network coding research group because we think the authors there will be able to chip in with their own schemes once we sort of start describing the blocks.
Cedric had posted a emailing about had some drafts, but had some other stuff too. So it's definitely if anybody has any input for Morten, please feed it to him via the mailing list, and we look for that.
I think it's a good idea, but if you want to do a survey, you have to refer every words, even some similar. I think you have to.
So I'm not doing a survey sort of to write an academic paper. I'm doing a survey to find the functional building blocks that are needed. So it's okay, I think, that we filter. I don't want to read every paper on sliding window. I just.
If you don't want to do an academic stuff.
Would you mind talking to the mic? We have online people.
If you want to do an academic, not an academic, you said. Okay. If you don't want to do an academic, it's simple to do a technical paper. And you don't have to cite, or you just have to say there is some schemes and we can use these schemes. If you want to do a survey, you have to cite everything existing. Otherwise, it's not a survey.
Okay, so what we will do is we will put out what we have done so far, and then if you know something that is not included, then I would encourage you to add it there.
But it depends on what you want to do.
So I think the goal of this exercise is that we are looking at making sure that our requirements that we develop for potential specifications for network coding are broad enough to address the needs of different approaches to sliding windows. So Morten's goal is really not to, like he said, read every single paper on one technique, but to find the array of different techniques that can be applied.
Yeah, so exactly, like if people are doing like coefficient selection in a special way, that means that building block needs a specific additional functionality that we didn't think about.
One thing we could possibly do would be create a wiki page on the site that kind of accumulates the stuff, and then that way if there are some duplicative things found, we could basically post them there and maybe bend things a little bit to help others see how things relate to each other. But we wouldn't necessarily have to include everything in your document, but kind of use the wiki as kind of a living document for that kind of purpose. So certainly would help do that. And yes, someone is pointing out that our site has not been updated. The wiki has not been actively updated, and we need to tend to that. So that's a good point. Yeah. And so we encourage other people besides us to be able to make changes to the site.
Just wanted to thank you for doing this. This is great, and especially encouraging is that what you just said, that they're mostly pretty much similar. So it is encouraging for us from the point of view of whittling down to narrowing down to something that is practical, and further down the road to maybe put something in a protocol. Thank you.
Okay, we're doing a good job of staying on schedule. The next portion was to have some discussion on the tutorial that we've talked about on the mailing list, and we have a couple outline slides here to talk to that about. Basically, the next slide after this is kind of a very strawman outline of what we think might be useful to put into a tutorial. The target of doing the actually, this is the outline.
Yes.
I'm going to take the liberty of presenting these slides backwards.
Yes.
Anyway, the idea that we've had is to basically get more information out to the IETF community on what the heck network coding is and what the heck does it matter to them. And we think that, I personally think, and Lars had suggested at one time, if we come up with something that we think is appropriate for an IAB technical plenary session, I think we would actually get a much bigger audience than other means of getting the information out there. But that would be a fairly constrained time period, and we would need to craft the content carefully to hit the very broad audience that we have. And so one of the objectives is to take this outline that we have on the other slide and kind of bash it a little bit here verbally. There is some existing tutorial material that Frank and Muriel have done for IEEE and that kind of thing. So I think it's a matter of culling that tutorial material down and bringing in some of the context of what we've been discussing in the network coding research group for how we think network coding can apply to the big I internet, and condensing that down into what's described there. And Lars may have some more guidance for us on that.
Lars, who's been at the plenary this morning where a tutorial was given? Okay, so you kind of saw how that worked, right? So we did 4 dry runs with those speakers. So they went through the entire thing 4 times, and they still ran each about 10 to 15% longer when they actually did it live. But this is a significant sort of step, right? Because we know that Frank and Muriel are giving tutorials a lot. All these guys are giving tutorials a lot. We still want to do these, and plus the IAB plenary is the IAB's time to hand out, right? So the research group can make a proposal for the topic, and I will certainly support that, taking it to the IAB, but it's their time and it's their decision. The level of, you saw it this morning, right, needs to be generally understandable, so you can't, or you shouldn't deep dive into formulas, for example, right? That would probably get you some very interesting questions at the microphone. Right. So there's so an IAB plenary is quite an effort to pull together, and if you want to do that, that's fine, and we can start a discussion. Having a plenary in another form is a very different thing, and it's in some sense easier because you can organize it yourself, and other than getting the room, which is easily doable. Lots of research groups meet on Sundays already. It's basically your thing to run. You do have probably a much more limited audience.
A much more small. Right?
Yeah.
So my personal opinion, and Lars, you may have an opinion on this too, would be possibly to try to focus on getting an IB presentation together first, and then for the really hard determined people, have a subsequent more deep dive session at another format. I don't know if. I know it's easier, so it's probably easier to do this one first than the other, given the constraints of IAB scheduling. But I think the value proposition might be worth.
So if you wanted to have it in Yokohama, you basically need to talk to your IAB now.
Yeah.
And the presenters basically need to commit now to be in Yokohama, and they need to probably commit to more than a single day because so in this venue, so normally the IAB plenary isn't in the morning. Right, it's in the morning here because that was the only way we could make it work with the rooms the venue had, because we had so much pressure for time. So this agenda changes may happen, right? And so if busy speakers want to just parachute in, probably not going to work so much.
Yes, I understand that, and I think Frank, you're still here, right? Good.
I'm Andrew Sullivan. There is one more thing that I will ask you not to repeat outside of this room until later today, but there's an additional thing for Yokohama, and that is we appear to have promised ourselves that in Yokohama we're going to have one plenary, and it's going to be limited to 2.5 hours. So the technical and admin plenaries are probably going to be together. So you're going to be really constrained in Yokohama.
I'm personally not anticipating us being ready for Yokohama. Anyway, I mean, other people Yeah. And actually, Muriel Medard, who we think may be a good candidate for doing this if we can get the scope of the content right, she even in an email hinted at Buenos Aires as maybe being a better target for her. But we'll take Lars' comments as far as making sure we have commitment and maybe a backup plan. And I do have a question for Lars, and then we'll take your question. Is how did you conduct the dry runs? Was that something?
We did 2 over WebEx and 1 this morning before the plenary live.
Okay.
And they each did an individual tech talk to the IAB. Then we had 2 where they went back to back together and then 1 live.
Okay.
Steve Botsko, I just had 2 other suggestions. If you had demo technology of some sort, you could show it at Bits and Bytes. You could also try to do one of the lunchtime sessions, which would be more under your control, and you would be able to handle you'd probably have a little more time. Yeah. So you have other options in these 2.
I do think we have people here who are interested in demoing stuff. As a matter of fact, at this longer deep dive, it was actually some discussion of even having kind of a hands-on kind of experience of some kind. But that's a good comment on Bits and Bytes in the lunchtime session. And as a matter of fact, the very first network coding research meeting we actually had a demo in the room, which didn't really work well. But as far as the demo was great, it just didn't work in the context of the meeting as well. But it was good, and I think that would be good to. We didn't get a lot of people seeing it, so it might be good to, have a place for a demo type thing to be held. So yeah, appreciate the comment.
It's Andrew again. So like I can't speak for the IAB, right? It's going to make its own decision. I am just a poor servant, but yeah, well, as Fred Baker likes to say, right? The reason your chair is because everyone wants to sit on you. So the other thing that I would say is, well, first of all, personally, I would say I would encourage this because this is interesting work, and so it's cool, and that's part of the goal of the technical plenary is, in fact, to show interesting things and get people excited and so on. But the other thing that I would say is there's no requirement that you do like sort of one technical topic at these, right? We could do all kinds of things. We've got lots of flexibility. So if you don't want to do something that's quite so long or whatever, you could do, some shorter things or different kinds of stuff. We could have more than one presentation. We don't like to have too many, but sometimes, for instance, what we've done is we haven't had a technical speaker, and instead we've highlighted various parts of the IAB programs. So instead of highlighting one of those, we could do some of this as well. And in that case, you can do 15 minutes or something. So you can think about a lot of different ways you could do this, and I encourage you to do it because we really do want, broadly interesting, cool topics at those things, and we want them to be widely interesting to the rest of the IETF. And I think this is generally a topic that is pretty cool and interesting that way.
Yeah, that actually might help us address some of the scope concerns that we have if we had a more high level but network coding technical segment, and then maybe a more internet applicability kind of presentation that was a short thing, and maybe even have co-presenters presenting those two parts or something like that. That's the kind of discussion I'd like to actually open up the floor to. Let me pop back over to the, finally, if we do capture some good material in a tutorial and we can manage to jot it down as an informational RFC, I think that would be a potentially good working group product, particularly if it addressed those two different areas that I just described in a complementary fashion.
I just want to repeat it, what we also discussed personally, Frank Fitzek, Theo Dresden. The thing is, we have to make clear what is the message we want to give to the other groups. It's not for ourselves, right? We know what network coding is. We have to find out which groups could be interested in that, and also lay it out what is the basic concept, where can they earn something, right?
Yeah.
So that is something we have to understand. How can we make it easy for them to grasp, how to integrate it into their ideas, and what they would gain out of that.
Yeah, I mean, we in our previous discussions here, we have identified possible points of outreach and liaison. Like I'm involved with the MAN-A working group, which definitely because of the packet loss of those environments, network coding possibly has a big benefit to those if we can squeeze it down into something software-defined networking, and it provides an opportunity to use network coding. And actually, I went to a BOF yesterday for deterministic networking. And some of the IEEE protocols for 802 TSN already use redundancy in delivering streams over multiple paths. So why don't we give them some smart redundancy instead of dumb redundancy with network coding? Certainly, there's going to be implementation constraints if they're doing it in hardware instead of software, but that's certainly a forward-looking use case, I think.
And Lars, you could also find people who are using it commercially, and maybe it's a limited deployment, right? Maybe it's military, or maybe it's some academic test, but something that actually demonstrates some actual benefit, and have that part of the motivation part of the tutorial, so that people actually realize it's not just math, it actually
saves
it's working, and it has some concrete benefits for some people, and then talk about how that could be applied elsewhere and maybe as a broader theme. So show benefits.
Hey, it's green. It saves energy.
Yeah.
Yes, sir.
So I guess I'm probably to some degree representative of your target audience rather than as this group.
This is great. Yeah.
But I think one aspect too, which I've seen in some of the papers, is the potential use of network coding to improve security. And I think that would be a particularly relevant topic.
Yeah. We haven't had a lot of activity in this research group on that particular area, and I certainly would welcome future presentations if somebody has one, and that's why I actually, is Angela still here? I don't know if she mentioned in her slides that one of the cost actions is looking at security, and that would be certainly, if they're willing and able to come to a meeting sometime and give us a little talk on what their thoughts are in that area, that would be of interest, I think.
Lars, you might want to talk to Kostin Raishu. I don't know if you know Kostin. He used to be my Candley student. He's one of the guys who did multipath TCP originally.
Okay.
And they have a thing ongoing. I don't know if it's published yet, but it's basically, so I don't know if they're using network coding, but they are applying some sort of coding / crypto to the multiple streams in a multipath TCP connection with the intent of making it extremely difficult to do a full take by a nation state adversary.
Okay.
And that could be sort of a pretty nice application.
Okay.
If they in fact use network coding. Which I don't know.
Hi, William White. Just another interesting application in the vehicular communications space where we're looking at using some form of network coding to distribute CRLs to vehicles in a peer-to-peer way. CRLs are certificate revocation lists, and those are large blocks of data that need to be authenticated. We're looking at questions of what size. Should they be split up into smaller chunks which are each authenticated? What's the best way to do the coding, that kind of thing? And actually, if there's anyone here who's interested in participating in a project on that, I'd like to talk to you afterwards.
Okay, yeah, and certainly if you have some use cases to present to a future working group meeting, we would certainly be open to that if you have. And it might help you get people aware of what you're doing and participation too. Yes, and somebody from Jabber has mentioned there was talk of network coding in the information-centric networking research group too. And that's one of the reasons that we formed this group, is we saw it sort of sprouting out into different research groups and working groups, and thought that we needed to maybe help provide a little integration point for all these folks that are looking at network coding to get the consolidated viewpoint, and maybe, again, if we're lucky, some common building block components, which sort of takes us towards the architecture discussion a little bit. But I'm certainly interested in anybody's input on the outline that we have up here. Is there anything that we don't think would be worth, we should put on an agenda for something like an IETF plenary, or is there something that we're missing here? And I certainly encourage lots of input on the mailing list, even the order of this. We have some material. We were going to get, Muriel was going to post material, or let us post material on the wiki that she has as kind of a starting point. I think Frank told me it's like 300 slides. Is that right, Frank? So we definitely need to cull things down. And so we need to work through that process. That's why I don't think we're going to be ready for Yokohama.
Right. So, Lazar, I think the first decision you want to make is if you are, so there's a tutorial that is valuable that is sort of for a general audience, and it's much more about the why and the what rather than the how. And sort of your middle bullet there that is confusing, you also named one.
Yes, I noticed that. one, and two.
So the second one, I think for an IAB plenary, I would probably, touch very lightly on. Although if you're doing a Sunday thing, right, you can actually maybe go a little bit deeper into the, the how part of it.
Those were bullets, and Apple made them in numbers.
Apple doesn't like bullets.
Doesn't like bullets.
Okay. Thanks, Lars. I guess I'll slide over to the network architecture slides. Again, don't expect that we've solved world hunger with the next revision architecture, but we wanted to have a little discussion on it. We think we need to clarify some of the terminology that we were using with respect to what is a building block versus more of a. So there's been some discussions, and Victor's captured those discussions in some slides, and we'll talk through them. Just let me find that presentation real quick.
Okay, so the motivation here is that we started this discussion, and unfortunately we didn't have enough time in the previous meeting. We got a little rushed, and I'm certain there was some misunderstanding, so I rewrote it with the inputs from Vincent, Morten, Brian, and many others. So, so here's the. If you go next. Oh, sorry. Yep. That doesn't look too good. I'm gonna blame on Apple.
Yeah, it is.
Yeah.
And it's funny. It didn't look like that on my screen earlier.
Yeah, I should have put it through PDF. Okay. So I apologize for the weird colors and that may reflect the state of our understanding.
So I think, I mean, yeah, Victor can talk to us. I think the main point here is sort of those black, I don't, they were a different color, I think they were blue, ovals that try to group what potential building blocks. We named some different building blocks here, and some of them there were existing RMT building blocks that may or may not be relevant to.
Right. This is even an older version.
Yeah.
Can you bring up the?
Okay.
Yeah.
This is the one that was posted on the.
Not the last one.
Okay, should I re-download it?
Yeah, if you could, please.
All right. One moment then. Or do you want to plug your laptop in to make sure you have the right version?
Okay, so the goal of all this exercise is to understand what are the elements, we call these building blocks, but really are functional elements that would produce some protocol instantiations later on. So given all the systems that have been developed and the practice and the experience that we have gained over the years, the idea here is that we would distill.
That's the posted version. So.
In meeting materials.
Yes.
Okay. Anyway, so it's close enough. So the idea here is that the different elements that we have identified in the past discussions and on the mailing list, we grouped them in several function areas, and kind of following in the steps of and the experience we had in the past few years with reliable multicast, taking a clue from the process that happened there, starting from a research group and then going into standardizing some protocol instantiation in a working group. The idea here is similar. Understand what the general functionality is. Identify the building blocks that can create that functionality, and then define the interworking between these building blocks, and ultimately decide and whittle down the different protocol instantiation into just a small set, maybe one or two that can actually be eventually standardized. So to give you some example, starting with the middle one with coding functional area, we would have obviously the random linear, there's deterministic, there might be also nonlinear, and maybe others. All of them have in common the fact that we are coding over a set of data, and the definition of that function will help understand how that will be used for the reliability transmission. Now on the reliability, I give some example. Obviously, we've talked today about the sliding window. There is also the classical block-based reliability, and these few blocks here represent different ways of doing feedback, how to convey and what to do about that feedback. For example, you can just say you can just have a binary, I have enough or I don't have enough, like an egg, or do an outspace sample telling more about what I'm missing. What do I do with this feedback? Can it be an end-to-end, or maybe just a local hop-by-hop? The combination of what kind of feedback, what kind of, is it block or sliding window, creates a certain functionality that might be useful for a certain application. Okay. Together, picking the left side is also an area that is very much unexplored from the point of view of network coding. It has been explored in other contexts, but I put a lot of question marks there, saying that we might use, for example, that TFMCC, that's the formula-based congestion control that is used in NORM, for example. Is that good enough for, say, a unicast or multicast using network coding? Maybe not, because of some specifics of network coding having to do with breaking down an end-to-end flow into something more like that has some elements of store and forward. In other words, the flow on some links may be very different than from another links or hops in the flows path. Now,
I would also make a comment that work from other working group areas are applicable too, like if multipath TCP is tackling multipath congestion control and whatever fairness means across competing multipath flows, some of that results of that work could be relevant to if those happen to be network.
It is absolutely relevant, but it's probably not sufficient.
Yes.
Because we are dealing here potentially with even a more general topology. So in the multipath TCP, you have non-intersecting path. Here you can have paths that split and merge with partial flows.
So that's actually not correct. So multipath TCP. So so SCTP never figured out how to do congestion control if you might have a shared bottleneck or your paths converge somewhere and you don't know about it. Mark Henley and Kostin Reicher, the same Kostin Reicher I met earlier, they came up. There's a SICOM paper I think on it. They came up with a congestion control scheme where you link the congestion controller reactions along the multiple paths, and so they're safe to use if there's a shared bottleneck in the middle. So multipath TCP is actually, and that's why we decided we can standardize this for use on the internet, where you don't know that all your paths are dissimilar.
So I think there is an added, I agree, and thank you. There is an added twist here where the flows different from the multipath TCP, where the flows can intersect in the same bottleneck, but they don't merge. Here you can merge the flows.
Correct.
So that's an even harder problem.
But so it might actually make you more applicable for multipath TCP, because multipath TCP already handles the case where things merge, and if they happen to merge where you live, right, you can do something more than they currently do, which is just forward stuff.
Exactly. Yes.
Actually, we at one point, Victor and I had a fairly philosophical discussion with Kevin Fall regarding congestion control, and one of the things that's interesting about network coding is the transfer of information is not necessarily equal to the transfer of packets, and particularly if you have a network that has different loss conditions on different links, you may be expending more packets in some part of the path on some path, but your information transfer is not so much. And if your congestion control is concerned about information transfer versus resource utilization,
you have something like this also with multipath TCP, because it has these separate subflows, and it does it does reliability at the subflow level, but it also does it at the connection level, which is and so you do get information about losses, or you can get information about losses that happen on one path, because you're seeing acknowledgement for data, connection level acknowledgements for data on a subflow that goes on a different path. So there's some, I think, my head explodes when I think about this too much, but you guys have maybe bigger heads and can figure it out.
It's a hard problem for anybody's head.
It's definitely a harder problem, yeah. Okay.
What's resource fairness when all resources aren't fair or equal?
So the goal here, just to finish this, so the goal, unfortunately, this is not the last version. Something happened with the meeting materials there. So the goal here is to have first a framework. I would say a relatively small document that captures the high level of organization of these functional areas, gives the examples of some building blocks and their functions without defining anything, just explaining what the function should be, and possibly also getting into how they would interact. And then at the end give an example of how you would combine, pick one of each and combine it into just an example protocol instantiation. And this would be a framework for actually down the road, first defining real building blocks. For example, we talked with Morten just today about possibly writing a building block about sliding window. There could be obviously another building block about block-based. Random linear, obviously there is one. All the feedback stuff here could be one. And ultimately, this would become inputs into some standardization process, hopefully not too long from now. The main goal, ultimately the goal would be to have some protocol instantiation similar to what we had, you guys had for the reliable multicast. What those protocol instantiations should be, it's not the purpose of this document. This is to be determined. And by the way, all the blocks that I've put here are for example purpose. This is not going to be a requirement.
Very notional. These are made up things. There's no, some of these don't. I think also one comment I have is this is sort of one view of the architecture. What I found interesting about what the cost action folks did was they actually have the different domains, which lets them have different views of the architecture. And I think that's important to capture something as slippery and slidey as a architecture, is to have those different views. And I would ask if Angela's still back there, this sort of aligns with your functional domain, but it also has elements of the protocol domain. And I think we could use your guys' help on maybe how
I was now warning to do this. I do understand this, but if you want someone else to understand, then maybe you need a bit more structure in here. And this is exactly our proposal. So that, because what I believe is that what you call building blocks are coding things. Well, some of them. Some of
I mean, actually, ultimately, at least in the case of RMT, a building block was equal to a RFC or a specification for some component, and then we would have protocol instantiations that reference multiple of those components to do something, do some work, and a network coding. I like to use the word network coding system to address a use case as opposed to a single protocol, because I think it's going to be even multiple protocols in play to do real network coding where I have topology information that needs to be considered and collected to...
Exactly, but I think what is new here, and that's why it brings a bit of confusion, and what he said with TCP multipath, is that we are confusing here what is mathematical, which is the coefficients, what you do with that, which is the flow, and packets, the physical packets. This is a mixing up. So in our proposal, what we try is the coding thing. Then here everything is mathematical.
Right. So in the
and then there are the mappings, the mappings to this world.
Right. So some time ago we had this discussion about the taxonomy, and we got into this discussion about symbol versus packet, and that's what you mean by that. So we have defined the symbol is that element of encoding which may or may not map to a packet.
Yes, but it remained at the level of terminology. Now you have to map that terminology with ontological domains, no? What belongs to what? Because that terminology now you're mixing up here. It's mixed up here.
So this is again a very high level view, and this would be described specifically in the particular building block definitions that will come later. So my proposal, the discussion, and I think we are converging it toward this approach of, it's essentially a modular approach, rather than looking at one protocol with everything and then maybe another protocol with everything. We found that based on all the prior experience, there are many common things, and those common things we are trying to tease out as this building.
I think it would actually be useful. We actually have a comment from Jabber on this too, particularly while we have your attention to this, to maybe look at some of the use case slides that we have right immediately following this. Oh, yeah, you still have those here.
Yeah.
We actually have like, was it 4 different use cases?
Was 4. I can bring up
that basically
also.
involve invoking network coding functions at different layers of the internet stack. You know, one case is enhancing the performance of existing transport protocols that's outlined here. It ranges from that to
no, but I only selected 2 on
okay, we don't have all our use cases here in the slides. I'm
Yeah.
sorry, but I think if you have an ability to take a look at some previous meeting materials, we can provide them to you to help us maybe take our use case views and.
This would be great because will be already the interaction.
Yes.
You know?
Yeah.
That's the whole point.
Exactly.
To
Interaction
get to a
with
common
different,
understanding.
exactly.
Mhm.
And I could also even with have a bridge with the mathematicians, so we have the maps, proper maps of what you are saying and what is the mathematical objects.
Okay. Thank you.
Thank you. Yes. Yeah.
Okay, so that's pretty much. If you go back to
Here or
no. What? Oh, you have it. So there you go. You have one slide. Okay, this is it. It's still the old version.
Yeah.
This is what I had in mind in terms of how this architecture/framework document would look like. Looking a little bit in each functional area, having a summary of what would actually do and how they interact, and that would be the starting point for getting into the building block. And as you note here, each of these has a question. Still the old
this is
version.
again where we can get input from
Right. So
each
each of the
multipath TCP folks. Once we make it clear that we're raising our hand from the network coding research group and say we do have congestion control to worry about. Anybody out there want to help us figure it out?
So each of these functional areas still has open research issues.
Yeah.
So this is a vehicle to both get us to a path to describing more in more detail the building blocks, but also at that time identify the open issues, and that comes back to research and to other working groups, not just us.
Yeah, I think that actually be a valuable aspect of this document. If we identified those areas we think are open research areas, that would be a use to the community, I think, to help close those gaps over time.
That's pretty much it.
Yeah.
Are we?
We're actually 5 minutes ahead of time. So anybody have any comments or questions? And really appreciate everybody's participation today. And please encourage people to let's try to step up our game on the mailing list a little bit. I think we actually have a lot of good things to talk about, and I think what Morton's doing, looking at the sliding window stuff, we can kind of get a dialogue going on some of this architectural stuff, particularly if we can interact with the cost action folks. I think we have some good thoughts there that we can probably make good use of, and hopefully that's to your credit and benefit for us to use your output. Anyway, thanks for participating, and make sure you sign the blue sheets, and see you next meeting. I'll
I haven't seen you in a while. Yeah, you have your feedback while you're still around. It's hard to see you.
Yes, because I have to find credit for him, funding to send him at the IETF. Sometimes I don't have any funding for myself, so I give the preference to my.
But I want to hear your
Yeah.
Anything that's
Yeah.
good, not too good,
Yeah.
sideways.
Okay. I have some comments about your last slide. I'm just wondering whether you. I think it's the case that it can be a very good objective. Okay. Because it's quite fresh and I was other previous control guys, and they try to do exactly the same thing. It's try to build the kind of middleware when you can have adaptation and selecting the right process, the right component to be the most performant as possible. So I think
That's what I'm sorry, I missed that. So I missed that meeting. So are you talking about selecting?
Yeah. Yes, thank you.
Okay, so this was not